No, I don't take shit, I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no, I don't take shit, I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks. This and that, spitting slow, spitting fast. I could roast, I could gas.
This project is designed around the principle of an open system, also known as control volume. In this type of system, both energy and mass are actively exchanged with the surrounding. To break down the basic concept, heat energy is supplied to our system using a stove. As the water inside absorbs this heat, it undergoes a phase change and turns into steam. Because this steam then exits the container, we are seeing a clear demonstration of mass transfer. Finally, while the energy is being added, we acknowledge that some heat is lost to the surrounding because of this continuous flow of both energy and mass. This project serves a perfect example of an open system.
This is our project proposal. The main concept is the conversion of thermal energy into mechanical work. The heat from the stove will produce high pressure steam which flows into the syringe and then pushes the load upwards.
This is the schematic diagram of our project. The stove will transfer the heat at the container, then the steam will exit from the container and lift the syringe plunger to level 1 to level 2.
This was our first discussion session to determine the direction and design of the project. We divided the task and contributed ideas to ensure that the steam mechanism concept could be implemented effectively. We chose to use coins as the load, which are 4 grams, 8 grams, and 12 grams. Among materials that we use are can, tape, steel epoxy, reamer, screwdriver, and polyurethane tube. This is our discussion during assembling the project. We conduct experiment to test whether we can make the project go or not.
This part is our adjustment for the project to make sure the steam can push the load from the syringe.
This attempt without using any load. The time taken without load is 21.65 seconds. Now we will put 4 grams to test. The time taken for 4 grams is 32.82 seconds. Now we test it can lift 8 grams. The time taken for 8 grams is 45.45 seconds.
And now we will test the 12 gram. The time taken for 12 gram is 1 minute and 17 seconds. This is our graph for the experiment. It shows the weight, time taken, and the time in seconds.
Is my comment on Thermodynamic 2. Thermodynamic 2 is not just about calculations, but also educate students to understand the reality of real system in a more systematic and disciplined way. Alright, thank you.
My comment for Thermodynamics 2. The second law of thermodynamics is important because it explains why energy losses are unavoidable in real systems.
Studying thermodynamics as a mechanical engineering student was demanding, yet it sharpened my problem-solving skills and taught me to respect energy limits, both in engineering system and in myself.
Entropy may be inevitable, but our quest to harness and channel it fuels the progress of thermodynamics.